Hi guys, and welcome to Chapter 10. Chapter 10 is Vectors and Parametric Equations, and as you can see, we're going to start out with some toolkit time. So if you could grab your toolkits and open up to page 58, we've got some definitions and things that we need to work through. First of all, what is a vector? A vector is a quantity that is represented by magnitude and direction. Magnitude is length, and direction we will find by looking at the angle that that arrow is on. And again, this will be from the positive x-axis. To name a vector, there are a couple of things that you can do. So for example, let's say I just draw a vector and we call it PQ. I can name this vector just like we did in geometry as a ray, PQ. Okay, so that's what this first piece means. Name a vector using an initial and an end point. I cannot name it QP because this would represent that the vector starts at Q, and it doesn't start at Q, it starts at P. So this would be wrong. Another way that vectors can be written is in component form, and this is what we will predominantly use. And we'll talk more about this tomorrow. But component form is, I've got an example down here. Instead of using parentheses, we use these pointed parentheses, I guess. And so it talks about the horizontal and vertical components. So A is going to be your horizontal, and B is going to be your vertical. Okay, and again, we will do some examples that will help in a minute. The other thing that you're going to use quite a bit is bearings. When we get to word problems, it will always be using bearings. Now, bearings is a totally different way to measure angles. We are used to measuring them from the positive x-axis and rotating counterclockwise. Well, bearings measures clockwise and from due north. So due north would be our positive y-axis. You'll often hear sailors or people that are out on the sea measuring in bearings. All right, let's try some examples. So if you could grab your note sheet, we're going to do some examples of sketching some vectors and talking about what is their angle and magnitude and how do we write the vector. So it says an introduction to vectors. A vector represents the movement in horizontal and vertical directions, in other words, x and y. The angle is measured from the positive x-axis, and that is called the standard angle. The length of the vector is called the magnitude, okay? Things that we just put in our toolkit. So we're going to work through this, and I want you to put a few notes on your sheet. It'll help you. So remember, we just talked about the x is your horizontal movement, and the y is your vertical. Okay, when we start talking about angle and magnitude, this is always going to be the angle from the positive x-axis, okay, and then comma length is your magnitude. Okay, so for this first one, my angle is 0 degrees and my vector is 2 units long. Okay, and let's just look at it. It says step 1, we're going to take move 2 units to the right. So bam, bam, 2 units to the right. Well, it gave us direction and how far to go. Okay, let's take a look at the second one. It says 1 unit up. Okay, 0, 1 is my horizontal movement is 0, 1 unit vertically. It doesn't matter where you start, just start somewhere on your grid and you're going 1 unit up. Okay, so if I'm going 1 unit up, what angle measure did I rotate through? 90 degrees. And I went up 1 unit. All right, let's take a look at the next one. Whoops. So the next one says back 2 units. Back 2 units just means that I'm going to go left. Sorry, technical difficulties. My paper doesn't want to move correctly. And so I'm going to be, let's take a look. Horizontal is 0 and my vertical is -2, which means we're just going to go down 2 units. Okay, so how do we write that? Well, if we went down, think about from the positive x-axis. So I know I didn't give you a grid here, and we won't give you a grid when you're drawing these just random vectors. What angle measure did we rotate through? Well, that's 270 degrees. 270, and we went for 2 units. Okay, the next one says we're going to go up 1 and left 1. So in my x direction, I went left. In my y direction, I went up. Okay, where did I land from where I started? That's what the vector tells us or represents. So I want to think about what is that angle that I would have rotated through. So if you're struggling with this, I would put your x and y axis where the butt of the angle is. That's at the origin. Okay, always. And so what is this angle that we rotate through? Well, we're going at a perfect 45-degree angle in that second quadrant. So 90 plus 45 is 135 degrees. Okay, and then how do we know that it's the square root of 2? Well, if I'm going left 1 and up 1, we're thinking Pythagorean theorem. So this is going to be -1 squared plus 1 squared equals c squared. So 1 squared is 1, -1 squared is 1, 1 plus 1 is 2, square root both sides. So we get the square root of 2. All right, let's take a look at the next one. It says left 2 units, left 2 units. Okay, so again, you're just picking, where am I going to start? Anywhere. And I just want to go left 2 units. Okay, and so how far did I go in the horizontal? -2. How far did I go in the vertical? I didn't go up and down at all. Okay, so what is my, let's put our x and y axis here. Here's the butt of your vector. What is my angle measure that we rotated through? 180 degrees. Okay, and how long did we do it? For 2 units. Okay, pause the video and try number 6 and 7 on your own, and then I'll go through them with you. Okay, I know that I'm going up 1 unit and right 1 unit, excuse me. So up 1 unit and right 1 unit. We're going to have a vector that goes again at a 45-degree angle. Up 1 unit and to the right 1 unit. So what angle measure are we traveling through? Well, it's a 45-degree angle. And how long did we do that? Again, I need to find that hypotenuse. We went 1 and 1. So 1 squared, 1 squared plus 1 squared is 2. Square root of 2 is √2. And I'm just going to write it as a √2. Okay, down 1 and right 1. So same idea. Down and right. We're still working through that 45-degree angle. So I know that, excuse me, if this is my origin, what's my angle of rotation? all the way around. So I'm basically 45 degrees away from a full circle. So that's going to be 315 degrees. And again, we did it for a length of square root of 2. Okay, and then what's our direction? In the x direction, we went 1 unit, and in the y direction, we went down 1 unit. Okay, moving on. All right, let's talk about equivalent vectors. It says in the graphs below, P and Q are called equivalent vectors, and they're equivalent because they have the same magnitude and direction. So if you look at P, if you start at the butt of P and go to the tip, we're going down 2 and to the right, 1, 2, 3, 4, 5. And same thing with Q. Down 2, 1, 2, 3, 4, 5. Okay, they ask us to find 2 other pair of vectors that are equivalent. Well, it looks like R and S are equivalent. Let's check they're pointing in the same direction, so let's check their magnitude. 1, 2, 1, 2, 3, 4, 5, 6, 7. So this goes up 2 and over 7. And this one goes up 2, 1, 2, 3, 4, 5, 6, 7. Up 2 and over 7. And so if I did Pythagorean theorem with both of those, I would find that my R and S would have the same length. So R and S is one pair of equivalent. And the other one, taking a look at that second grid, it looks like L and K. So I'm going straight north, 1, 2, 3, 4, and I'm going 1, 2, 3, 4 straight north. So my other set of equivalent vectors, L and K. Part B, it says draw a vector equivalent to X. Okay, so let's take a look at X. I'm just going to highlight it for you. So X goes from here to here, and so I want to go down 1 and to the right, 1, 2, 3, 4, 5, 6, 7. So down 1 and to the right, 7. Okay, and I can start anywhere, so I'm just going to squeeze it in right here. So I'm going to start here, go down 1, 1, 2, 3, 4, 5, 6, 7 is where I'm landing, and just connect. Okay, so that vector is equivalent to X. All right, let's try another example here. Moving on to number 4. So adding vectors geometrically, we're just going to line them up. The end of one will be at the tip of the other. So it says copy the vectors R and M on a sheet of graph paper. Well, we're going to just do it on the grid that we're given to the right here. And I have steps here that you can follow, but we're going to work right off of R since we've already got that. Right, whoops, let me grab my pen. So here's my R. And what I'm going to do is at the end of R, it says we're going to draw the vector the same length and direction as M. Okay, so I'm going to take M is 1, 2, 3 units straight south. So we're going to go 1, 2, 3. So this is M. Okay, and excuse me, it says that we want to draw the vector from the initial point of R to the end of M. So in other words, what we need to find is this green vector. They asked us to label this vector R plus M. So R plus M. And they called this the resultant vector. Okay, and we used the head to tail method for adding vectors. All right, so we just did part A. I want to show you how it works mathematically as well. Vector R was, I would write it as 7, 2, because my horizontal distance was 7 and my vertical distance was 2. And then vector M We went straight south, remember, which means my horizontal distance is 0, and I'm going down, which is negative. Well, look at what happens if I were to do this mathematically. Let's label this vector A. Let's label this one A. Okay, A is just the sum of those two components. So I'm going to add my x's together. I'm going to add my y's together. So 7, 0 is 7. And 2 plus negative 3 is negative 1. So if you look at A, did I go over 7? 1, 2, 3, 4, 5, 6, 7. Yes, I did. And did I go down 1? Yes, I did. Okay, let's try another problem. Part B. Copy P onto your graph paper. So P goes to the right 5 and down 2. Doesn't matter where you start. We're going to the right 5, 1, 2, 3, 4, 5, and down 2. Okay, take a minute to sketch that vector. And let's label that. That's P. All right, and then we are going to draw R plus P. We're going to label that resultant vector B. So R goes up 7 and over 2. So we're going to start where we left off. We're going to go from the tip of P. I think I said that backwards. We're going to the right 7. 1, 2, 3, 4, 5, 6, 7, and up 2. So here's R. My resultant vector is B, which is going to go from the tail of where I started to the tip of where I ended. And that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units long. All right, let's check it out mathematically. So P, we said we went to the right 5 and down 2. And then R went to the right 7 and up 2. So it should make sense that B, our resulting vector, 5 plus 7 is 12, and that's exactly what we counted. And we went up and down 0. Let's go back and label our vector. So this is vector B. All right. Part D says, using your observations from part C, make a conjecture about adding vectors. Oh, well, guys, we already did that. Our conjecture would be that if we add our horizontal parts together and our vertical parts together, we should get the resulting vector. All right, let's try one last example. All right, it says in the diagram below, vector V is added to vector U, which is not shown, to get the resulting vector W. What is the component form of W? In other words, they're asking us for our horizontal and vertical components. I would start by finding V and W. So we can see that V goes down. I'm sorry, I should go to the left and right first and then up and down. I'm just so used to doing slope. So it goes to the right 2 and down 3. So that would be my component form, 2, negative 3. And W goes left 3, so negative 3, and down 1. So what this question is asking us to do is to start with V, add something to it to get W. Well, let's think mathematically here. If we start with V, add something to it, which they're telling us to call it U, and we get W. All right, well, let's talk about our components. So this is going to be 2, negative 3, plus some X and some Y, I don't know what those values are yet, is going to equal negative 3 and negative 1. Okay, well, if we put it that way, that's not so bad, right? Mathematically, you can think, all right, so this is really going to be 2 plus what gets me negative 3. Subtract 2 from both sides, I get negative 5. And negative 3 plus what gets me to negative 1. Adding 3 to both sides, I get a positive 2. So my u vector is going to be negative 5, 2. So hopefully you're a little bit more comfortable with vectors. Again, if you've been in physics, this is probably nothing new and you were just given a big review. Have a great day. Do your homework, please.